easy problem today. So we have two numbers, left and right. We want to find how many count numbers that have bits count is prime. So the solution is not very hard, because the numbers at most 10 to the power of 6, we can brute force it. To check this, the number is prime, we know that bits count is only 32, or 10 to the power of 6 is 19 bits. So just check the numbers and so on, one by one, and left, right, number in this prime set of primes. Also, now the shortcuts. The first shortcut is, for example, we want to have 19 is the biggest prime number, so we can check that number of bits is divisible by 2 or by 3, and for example, if we divide by 4, by 5, so on. So for example, 2 times 5 is 10. So if we have 10, you can check it is divisible by 2. I think we even can skip checking dividing by 4 and by 5. Only check by 2 and by 3. Also, the number 1 is always to remember not prime. It's kind of not obvious. Now the second shortcut. Let's look at my solution. So I use this count 1 bits and set off, and the solution is 100 milliseconds. Now let's look at the other different solutions. So this solution is bitmask. The interesting number of in the hex, it is 828 AC. So this is just a bit mask. Okay, 32 bits, and we have primes that pointing to the bits, like prime 1, it's the first bit, or prime 19, the 19th bit, and this is a bit mask of these primes. It allows us to a little speed up. We just check shift right by count bits and use this check of and 1. Now let's look at other solutions. You can pre-compute integer array 10 to the power of 6, but the time is not very good. And now the optimal solution is this one. So these are combinatorics. Instead of checking the numbers in range, we will check each prime. So we have prime 2, 5, 7, and so on. And each prime is a separate task. So, for example, how many numbers up to right has exactly 2 bits. So this is different task, different problem, and it has optimal solution. Now the solution is we checking, for example, we have number 12. It is bits 1100. Imagine we have to check up to 12, so the R equal 12. How many numbers have the same count of bits, exactly 2? We go on bit by bit, and if we see the bit 1, we asking ourselves if we move this 1 to the right, how many places it has. We know that we have total count of places, like 3. We know that there is a 1 bit left, so only 2 vacant places, and this bit is 1 in 2 different positions. So it is MCR to 1, and okay, so maybe I did a little bit wrong in this, but looking at the solution, it takes the NCR of I and then the rest of the bits. And this is the bits we have set, and this is the rest of the bits. So this is kind of combinatorics, and it's not very trivial. It's a hard problem with hard solution. The NCR is a Pascal triangle. NCR, it's computed like this: 1, 1, and this is a sum of the parents. 1, 2, 1, and so on. 1, 3, 3, 1. And this is J. So this is another solution. Now let's look at another one. It has interesting implementation. It is the same idea. We go on primes, and then we find the next number that has exactly the same bit counts. There is a known algorithm to find it in the bits set. Now this is kind of hard to describe because I don't write it myself, but this is works. So it uses, for example, we have bits, and we want to find the next number with the same bits count. So we moving this first one in a suffix to the left and then shifting the tail to the right. So the next will be 1, 0, 1. And this is how we checking until it goes to the right range. So that's it for today.